Assalamualaikum and a good day I bid to our beloved lecturer, Miss Shahirah Binti Aripen. This is the video of the final project of Process Control and Instrumentation. This project is focusing on the use of Programmable Logic Controllers, PLC, and Distributed Control System, DCS. This is the content of the video. We have an introduction which will explain the company's background and situation, and then followed by part 1, variables that need to be controlled. These parts are going to be presented by me, Ahmad Amjad. Next, NUlhakim will explain the second part, which will be focusing on instrument proposed that will control the variables. And lastly, part 3 and conclusion will be further discussed by Ahmad Danish. Part 3 is about the selection between PLC and DCS. Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Amjad bin Rafidi. My metric number is AA181269. I will be presenting the introduction and part 1. The name of the company is Technocast Sdn Bhd. The main business of this company is the manufacture and distribution of ammonia and other related chemicals. This company was established in 1982 and considered as one of the oldest ammonia gas supplier in Malaysia. Old company age means old facilities. The use of old equipment and facilities will alter the ammonia production efficiency. This is due to the maintenance problems that occurs when the equipment is used for a long period of time. The lack of advanced control system also contributes to the inefficient production, as massive costs and time can be saved with the use of advanced control system. However, this video will be focusing on the company's ammonia storage tank. Storage tank considered as one of the most crucial equipment as the end product is kept and stored in the storage tank for a period of time. The control engineering department suggested the company to do a replacement of old storage tanks with a new one. There are several reasons why the replacement should be done by the company. Firstly, this replacement will ensure the company have the most advanced technology. The maintenance cost will be reduced as the value of desired operational condition parameters like temperature, pressure and flow rate can be redesigned. In addition, the availability of spare parts of new storage tank is higher when compared to the old tank. Furthermore, the new proposed tank is more environmental friendly as it produces lesser pollution and waste. The Control Engineering Department have shortlisted 3 types of ammonia storage tanks. The first one is the smallest one as it only can store 2.5 tons to 150 tons of ammonia. This storage tank operates under ambient temperature and equivalent pressure. The second storage tank is the medium-sized storage tank that applicable to keep 500 tons to 3000 tons of ammonia. This spherical-shaped storage tank required a refrigerator system as ammonia will be kept under pressure. And the third tank is the biggest ammonia storage tank that is suitable to store produced ammonia more than 3000 tons. A refrigerator system will be used to reduce the ammonia temperature to -33 degrees Celsius. This storage tank will be operated under atmospheric pressure. The Control Engineering Department agreed to propose the third tank as it have the capability to store the highest ammonia volume. The biggest storage tank, which is the third tank, is required as the company produces a huge amount of ammonia. And now, I will be presenting part 1, variables involved. In this part, we are going to discuss the variables involved in the storage tank. The operational condition of the storage tank need to be properly controlled as we do not want any negative changes happen to the end product. There are 3 variables that we need to control in the storage tank, which are temperature, pressure, and flow rate and level. So the first one is temperature. The temperature need to be fixed at -33 degrees Celsius. This temperature is required as the ammonia in the form of gas will be converted into the liquid form. This is because the liquid form of ammonia is easier to manage and store than the gas form of it. The next variable that need to be controlled is pressure. The pressure need to be set at 1 atm. This control is crucial as an explosion can occur if the pressure exceeds 1 atm. If the pressure is below 1 atm, the ammonia will be vaporized. And lastly, the level of the ammonia in the storage tank. This variable can be controlled by controlling the flow rate of the ammonia. The control of the level of ammonia in the storage tank is vital, as improper control will cause overflow and may lead to leakage problem, thus damaging the tank. So how to control these parameters to be at the desired value will be further explained in the next part by Luqman.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Luqman NUlhakim bin Muhammad Noor, matrix number AA81719. I'll be continuing from Saudara Amjad with proposed input devices. Resistance temperature detectors, or RTD, are sensors used to measure temperature. The RTD element is made from a pure material which has a predictable change in resistance as the temperature changes. This change is used to determine the temperature. It is a passive resistance element, which means the RTD does not create any electromotive force itself. By using a known current, the voltage across the RTD is measured, which gives the resistance and consequently also the temperature. RTD are commonly used for applications in which higher accuracy than provided by thermocouples is required. RTD provides stable output for long periods of time, excellent accuracy and repeatability. The effective range of RTDs is principally depend on the type of wire used, which is a platinum 100 to 600 degrees Celsius, while nickel is effective in the range of negative 180 to 300 degrees Celsius. The second input device is pressure sensor. Sealed tanks such as ammonia storage tanks are required to be sealed from the atmosphere. Under this condition, a differential pressure should be used to calculate the difference in pressure. But due to the corrosive nature of ammonia, they should be protected by a material that is suitable for ammonia use. The pressure gauge should also be able to withstand the pressure. The suitable pressure sensor for ammonia is digital bellows sensor. It is sealed at one end with a small hole at the other. When the pressure is applied via the hole, the bellows expand. This displacement can be calibrated in terms of pressure. The electrical output signal directly related to the displacement input signal. The third input device is volumeter. Pure ammonia is stored in pressure vessel rated to 250 to 300 Pascal. Aqueous ammonia, 70% to 80% water, is stored in a tank rated for 25 to 30 Pascal. Storage requirements for aqueous ammonia are 3 to 4 times that of pure ammonia. A level measurement device for ammonia storage tanks must be able to withstand pressure and still measure accurately. Plus, the surface of the fluid tends to boil as it moves between states, and heavy vapors can affect measurement accuracy. Radar-based sensors, on the other hand, are ideal because low-frequency radar devices are less prone to attenuation and better suited to many ammonia applications. Ammonia is a hazardous substance, and it is important to protect operators from contact with its vapors, and most radar sensors are designed to be isolated and can be maintained away from danger sites.
Now, we will move to the last part, which will also conclude our assessment. This part will discuss about the system that we have chose for our company. We need to bear in our mind that we are buying a new storage tank for our company. It is important to get a tank that can store ammonia liquid in a condition that will not harm the surroundings and worker safety. As we all know, it can cause explosion without a proper storage. We have two systems to be considered. They are Programmable Logic Controller (PLC) and Distribution Control System (DCS). Normally, PLC is used for simple equipment that need the parameters to be controlled. For DCS, it is used for a more complex system such as plant that has many equipment and controllers distributed in it. This is a picture that we have prepared. As we can see, our group chose Programmable Logic Controller (PLC). The reason behind this choice is that our company has a simple and easy access plant. The company only produces ammonia and no other products, which means we do not need a complex control system. There are 4 devices attached to the storage tank, which are temperature probe, ultrasonic sensor, refrigeration system, and ammonia sensor that control the temperature, level, leaking detection, and cooling purpose respectively. Now, we will go further about PLC. There are 4 main components in PLC, which are input, CPU, output, and memory. Input represents the sensing devices that will sense any changes in the storage tank. CPU is needed to analyze input and transfer it to output. Memory is where the desired data or condition of the storage tank is stored for CPU to access. Lastly, output represents the devices such as valve that will regulate the condition of the tank. There are several advantages of PLC. Number one is that it has less physical wiring or wiring time. This is because the controller is placed near the equipment. Secondly, the cost is lower compared to DCS. PLC also allow the changes of conditions in the reactor to occur immediately during the operating process, as it works everything by itself with the data that is put in the memory. And number four is the system can be run by simulation without input. This can help to detect any unusual activities or potential hazards that can happen during the real operating process.